All right, question number 12. We have three parts. It says we're going to graph the function. We're going to identify the point A, f of A, where the function has a tangent line of 0. And then we're going to confirm it by making a table. So we're going to do this problem in its entirety with our graphing calculator. So I'm going to go to y equal, I'm going to clear out what we have, and I'm going to type in our new function. So we have x squared. We're going to subtract 12x, and then we're going to add 35. Okay. So we're going to graph this. Now this right above answer choice A shows us the dimensions that we want the window to be setting. So it always goes in alphabetical order, so the x-axis and then the y. So we want to be on a 10 by 10 window, negative to positive 10, and the same in the y direction, counting by a scale of 1. And if you wanted to change the window, you would have to hit this window button, and those are the normal settings: negative 10 to positive 10, counting by 1. Same thing in the y direction. So we go back to graph, and we get this image, and we can just pick the one that best matches, which looks like D. So we got a parabola. Looks like our vertex is 1, 2, 3, 4, 5, 6, and looks like at negative 1, that's the vertex. So when we do a horizontal line, that's a slope of 0, and that looks like that happens at this tangent point right here, tangent to the minimum, which looks like 6, negative 1, which we could work that out as well. So just recall some of your algebra concepts. You can do what we call the axis of symmetry. So if you remember from algebra, the axis of symmetry, which I'm kind of off the screen, the axis of symmetry would be x equals negative b divided by 2a, and then you can use this formula. Once you find the x coordinate, you would just plug in x for x in the original function, and that will give you the y value. So we're just reading off the graph. Looks like 6 and negative 1. So we're going to put that in. Got to type the order pair. Okay. So now we want to do the table. So in the previous problems, we have been inching ever closer to that point. So in this case, we're inching ever closer to 6. So in this example, A would be my 6, and my upper end would be 6.5, and we would just inch closer from there. So I'm going to go ahead and estimate based on the pattern that we've seen. And again, I'm going to let the calculator do all the heavy lifting here. So what we're going to do is we're going to go to stat, and it's going to allow us to enter some equations or different values. So it looks like we have, what, 4 or 5 more parts. So we're going to do this 5 times just for good measure. So 1, 2, 3, 4, 5. I got 4 in there, 5. Okay. In the upper, so these are my first x values. That's all going to 6, so we're inching closer to 6. Over here, I'm going to start with 6.5 because it wants us to be 0.5 above. And the going trend in the previous problems was 6.1, so we'll get a tenth closer each time. So 6.01, and then we would do 6.001, and then we'll go 6.0001. So these are my x values. Now in column 3, I'm going to have it find the y coordinate. So I'm doing the function as far as the slope is concerned. So I'm trying to get the calculator to output this. We're doing f of b minus f of a. In this case, my b is the upper point, and then we're going to do a minus b. Sorry, b minus a. Did that backwards. This will be b minus a on the bottom, and then it will give me my slope. So right now, I'm having it to do f of b minus f of a. I'm going to find the y values. Now, Because I have placed these values in column L1 and L2, I need to tell the calculator to grab them from L1 and L2. So when I type this function in, x squared minus 12x plus 35, I'm going to be using the variable L2 and L1 in the place of x, because that's where it's going to grab those values. So I'm going to go up to the top of L3 and we're going to start this equation. So we're going to say, instead of x squared, we're going to do our upper value, which is L2. So we're going to say second and then number 2, that's where the L2 is. We're going to do it squared, so this represents our x squared. We're going to do minus 12x. Now the x again in this column is L2, so we're going to hit second L2, and then we're going to add 35. So this is going to do my upper value, okay? Then we have to subtract. So what we're doing, we've done the first part. We've taken our function, plug in the upper value. We're going to subtract the lower value, which is going to be these values in L1. So I'm going to open parentheses again. This time I'm going to go second L1, and we're going to do squared. That represents our x squared. We're going to do minus 12 second L1 for our 12x, and then plus 35. So what this is going to compute is the numerator of our function. So when I hit enter, it's taking this function, taking these values, plugging it in, these values, plugging it in, subtracting them, and giving me the end result. So this represents the numerator. So now I'm going to put it all together. So I'm going to say in L4, I want you to take the numerator value. So I'm going to say second, take L3, and then we're going to divide that by, and we're going to tell it to do L2. So second L2 minus second L1, because we got to find those differences. We probably could have done that ahead, but it's okay. So we're taking the y value, dividing by the difference, that gap, which is going to be the 0.1, 0.5, and so forth and so on, and it's going to compute all of that for me at once. So this column is giving me the overall slope of all of those values. So we're going to input 0.5 for our first slope. Our second is 0.1, so it looks like it's kind of matching with the exact difference. 0.1. This one will give me 0.01. The next is giving me 0.001. And the last one, so that e to the -4, that means we're going to move the decimal place 4 times to the left. So it starts behind the 1, so if I go 1, it's 1 decimal place in front of the 1, and then I do 3 more to get 4, and that's how we're getting the 0.001. 0.3 zeros and a 1. So that's the calculator's notation for exponential or scientific notation. We have a negative exponent of 4. That's what that means. All right, so that gives me all of my slopes as we get closer to the number 6. And it says the slope of the tangent line, which should be 0. That's what we thought to begin with.